So here is a perfect holiday question. So James covers the entire top piece of pie with whipped cream, but he doesn't like to eat the upper portion of the pie crust where it's thickest, which I don't really understand because that's really the best part of the pie. So this tells us that EP and EI are radii of a circle. Okay, of course, we've got a pie is a circle. EP is 4 inches, so that would mean that the radius of the pie is 4 inches, which means it's probably an 8-inch pie, because usually pies are determined by their diameter. And it tells me that the measure of PEI is 60 degrees, so he is eating 1/6 of a pie. So let's talk through this. What in this situation refers to a sector of the circle? So the sector of a circle, if you remember, it's just the segment. So that would be the entire piece of pie. So there's some trivia at your Thanksgiving table that you can definitely bring up. That you can tell your relatives that they are eating a sector of the pie. Okay, number 2, what in this situation relates to a segment of the circle? So the segment of the circle would be this upper crust right here. Okay, if each piece of pie is the same size, how many pieces are in this pie? So I alluded to that earlier, that he's eating 1/6 of the pie. And I figured that out because if each piece, so we have 360 degrees of pie, and each piece is 60 degrees. When I divide that out, I get 6. So there's 6 pieces of pie. Now it says number 4, determine the area to be covered by whipped cream before James removes the upper crust. So that would be the entire sector of the pie. This dude loves his whipped cream. So in order to figure that out, we're going to do the area of a sector formula, which would be 60 over 360 times pi. My radius is 4, so 4 squared. And we're not going to leave this in terms of pi. We're just going to go ahead and divide it out. So I have 60 over 360 times pi 4 squared. So he is covering 8.37 inches or 8.38. We're going to go ahead and round that to 8.4 inches squared of pi. So actually that would be inches squared. To determine the area to be covered with whipped cream on only the upper crust. So now we're taking the upper crust away. So we want to find the area of the triangle. That's what we're trying to figure out. So this is not one of those nice ones that has a 90-degree angle, is it? It's a 60-degree angle. So what we're going to have to do is drop an altitude, and we're going to have to use Pythagorean Theorem. Since this is 60 degrees, all the sides are the same. So that's 4. This is going to be 2. So we can use Pythagorean Theorem, or if you can remember back to Geometry A when we did special right triangles, if you recall, we have a 60, 90-degree triangle. And remember that our ratio is x to x square roots of 3 to 2x. Well, my x across from my 30-degree angle would be 2, and we know this is 4, so this is 2 square roots of 3. So to find the area of the triangle, it's 1/2 my base, which is going to be 4, times my height, which is 2 square roots of 3. I'm just going to go ahead and stick that in my calculator. So we have 1/2 times 4 times 2 square roots of 3. So he's going to cover 6.9 square inches in whipped cream. Determine the length of the upper crust. And so I think this is supposed to say area, so we're going to change this to area. So the area of the segment, I take the area of the sector And I subtract out the area of the triangle. So 8.4 minus 6.9. 8.4 minus 6.9. And that gives me 1.5 inches squared. That's how much pie James is not eating from his slice of pie.